Welcome to an exciting exploration of a research initiative in the field of robot learning and artificial intelligence. While AI has made remarkable strides in language modeling, protein folding, and gameplay, the domain of robot learning has faced unique challenges. Moravec's paradox, which highlights the complexity of sensorimotor behaviors for AI agents, has contributed to a slower progress in this field. Additionally, the lack of standardized software frameworks and benchmarks has impeded efficient research and prototyping. This presentation introduces a remarkable solution to these challenges. To bridge the gap and accelerate the progress in robot learning, a collaborative effort from leading institutions including U Washington, UC Berkeley, CMU, UT Austin, OpenAI, Google AI, and Meta AI presents RoboHive. RoboHive is not just a platform, but a game changer serving as both a benchmarking tool and a research environment. It supports various paradigms such as reinforcement, imitation, and transfer learning, providing researchers with a versatile toolkit for investigation and prototyping. Let's delve into the key features that makes RoboHive stand out. RoboHive offers a diverse range of settings spanning different academic fields. These settings support tasks like manipulation, bipedal and quadrupedal movements, and musculoskeletal arm-hand models powered by MuJoCo robot class abstraction. RoboHive introduces a unifying robo class abstraction that seamlessly interacts with both virtual and physical robots, allows researchers to transition their findings from simulation to reality effortlessly. Teleoperation support and expert dataset. RoboHive provides out-of-the-box teleoperation capabilities via various modalities, making it an invaluable resource of researchers in imitation learning and related disciplines. Additionally, the dataset RoboSet gathered through the human teleoperation covers a wide range of real-world manipulation tasks. Fourth, visual diversity and physics fidelity. RoboHive sets new standards in physical and virtual diversity, exploring the next research frontier in real-world robotics. If you found this research intriguing and informative, please consider subscribing for more updates and click on the bell icon below.